Let's look at two planes. A three-dimensional diagram, if you keep it moving, is a little bit easier to see what's going on. Remember, whenever you draw a plane, put the normal on. So I've got that here, and I can see two planes interacting with each other. And you see that unless those planes are parallel, they're bound to intersect in a line. So what is the equation of that line is one of our topics. And the other question is, if we say, put it like that, what is the angle these two planes make with each other? Can you see that the angle that these two planes make with each other is the same as the angle that the two normals make, therefore making the question really easy. And so without the aid of software, this is the sort of question. Let's find the angle between these two. Let's find where they intersect. So we draw a diagram. This is what it inevitably looks like if you have established that they're not parallel. Now, when you first look at this question, you should be suspicious. Oh, look, it's 1, 3. Is it parallel? No. It has to be all three are a multiple of each other. They're not. Therefore, the diagram is definitely correct. So to find the equation of this line, we just need to know a single point on it and its direction. Now, its direction beautifully comes from the fact that the direction of the line is perpendicular to both normals, and that should ring a bell. And there we have it. So this vector here is perpendicular to the two normals, and therefore it is the direction of the line. And there's a lovely trick for how do we find a point that is in common between these two planes. We know there's an infinite number of them, but can we find one? And the lovely understanding is that this line is infinitely long. At some point, x must equal 0. I was going to say z, but maybe you can see why that doesn't work in a second. I'm going to say x equals 0, leading to normal simultaneous equations, two unknowns. Solve that, I get z equals 1, y equals a third. And I know that I said that x equals 0 there. I've got a coordinate that is on all three. Notice if I had said z equals 0, I would have run into some problems. And if you do that, then just say one of the other coordinates is x equals 0. So I have a point and a direction, and I have the equation of the line that is on both planes. Really nice. The angle between these two planes is simply the same as the angle between the two normals. So this is the formula. Cos theta is the dot product divided by the two lengths. The dot product is the easier of the two products, and the lengths are easy, so dead easy.